Okay, so today it's going to be a lot of live coding. So as the last one went, I want to do this to reinforce the concepts we've been seeing. We just had 2 lectures where I did a lot of stack and heap diagrams in the slides. Now I want to go to live code, run the debugger on that live code, look at the stack, look at the heap, look at all the implications of that. So as with the last live coding lecture, if there's anything you want to see, any questions, please, I'm doing this to show more examples for all of you to get a better grasp on the content we saw over the past 2 weeks. So by all means, ask questions throughout, hit the Twitch chat, or raise your hand, anything you want to see that'll help you understand the concepts better. Let me know so we can see it. Yes?
How does the debugger work on something that just returns unit?
Does the debugger work on something that just returns unit? When it gets to the end of that method call, it'll destroy the stack frame, but just won't return any value.
So you still see what it will actually end up returning?
If the return type is unit, nothing actually gets returned. So the last expression that's executed in a method that returns unit isn't the return value, just doesn't return anything. The lecture question, it looks like a lot of text, but the lecture question, a lot of this is repeated twice, so it's not quite as much as it looks like, but I mean, it's still somewhat involved. So again, we want to talk about references. Again, as I mentioned last time, drawing stack and heap diagrams, I really can't turn that into a lecture question, but you can count on lab next week being, here's a program, here's a breakpoint, draw me the stack and heap. And show me the stack and heap. That's what you can count on in lab next week. So for this, it's all about references again. Create 3 classes, a battery class, which is going to be similar to our valuable class from last time, where we want to make sure that these batteries are always passed by reference. When we move a battery, we want to actually move that battery. We don't just want to copy values from that battery. This time we do have an instance variable though. State variable, I've been trying to be consistent with state variable. Sometimes I call them instance variables too, outside of this class. But a variable in its constructor named charge of type int for how much charge does this battery have before it's dead, and each time we use the battery, we're going to use up some of that charge. A class boombox that's going to take a battery in its constructor. Oh my. It's going to take a battery in its constructor. So when you have a boombox, you got to supply some batteries, or one battery. Everything's singular in this, but you got to supply a battery, put in that boombox to get it to work. This boombox has 2 methods: use and replace battery. Use would actually have the functionality we're just simulating here. Use is going to drain the battery by 3 units of charge. If the charge is less than 3 when this method is called, does nothing, it doesn't change the charge of the battery. So if a battery has charge 2 and you try to use a boombox with that battery, it just doesn't do anything, and that battery should still have 2 charge after that call. Replace battery, this is where we really want to talk about the references. This is similar to the trade method from last lecture question, mainly with the same concept. We want to understand how these references move around. Replace battery is going to take a battery as an argument and return a battery as its return type. Take a battery as its parameter. So the battery that it takes, if I have a boombox, it's always going to have a battery in it. If I call replace battery, I have another battery that I'm taking as the parameter. I'm going to replace that battery, put the battery as the parameter in the boombox, and take the one that was in the boombox and return that from the method call. So I'm replacing the battery in this box. We want to make sure this happens by reference, so we don't just want to make sure that the battery that ends up being returned and the battery that goes in happen to have the correct charges. We don't care, I mean we do, but we don't care just about the charge. We want to make sure it's actually the same battery. We want to make sure that that swap happens by reference. So we don't want to create a new battery with the same charge as the one that's inputted and return a new battery with the same charge as the one that was in it. We want to make sure that these are swapping by reference. So we actually did change this object of type battery is now in the boombox. This object of type battery that was in the boombox is now being returned. So we want to make sure that that swap happens as the realistic, real-life application, actually swapping the batteries. Then a class named flashlight, very similar functionality as the boombox, except the flashlight comes with batteries. The constructor takes no parameters, and when a flashlight is created, create a new battery with 5 charge that'll be in the flashlight. And these batteries are always in a variable named battery. The batteries have a variable named charge. I am naming these, so when I name them in the problem statement, it's all fair game for testing in your test cases. Recall when, if I didn't name it and I just said a battery takes in an int representing its charge, that would mean you can't access that during your testing because we might name our variables something different. These, I'm naming charge, I'm naming battery, so you're allowed to use these in your testing, which of course there's testing at the bottom here. Flashlights come with batteries with 5 charge. The use consumes 1 charge of a battery. If the charge is 0, method does nothing. Technically, if it's less than 0, it should do nothing as well. We'll assume proper usage that we don't have negative charges. Could have negative charge if you give a boombox negative charge batteries. It shouldn't make sense. And then replace battery does the same thing as it does with the boombox. So we have the same exact functionality in both of the replace battery methods. And then a test suite, test batteries that test all of this functionality. So the key thing for your testing, of course there's some functionality. If I use a boombox with a battery of less than 3 charge, it shouldn't do anything. Greater than 3 charge, 3 or greater, it should decrement the charge of the battery. But the big thing we want to test is this replace battery, making sure that this is happening by reference. So how do we do that? In part of the live coding, I'll go over an example that shows that concept, that swap by reference concept. Just in case we need more reinforcement on that idea. And again, we can use the equal. We have 2 batteries. Use the equal operator, the equal method, sorry. Technically not an operator. We use equal, and that's going to tell us if they are referring to the same battery. Those 2 variables refer to the same battery. Any questions on the question itself? Yes?
When you create your test suite, you're going to have to call the use method, but how do you know which use method you're calling? Because you have 2 of them, one and 2 different.
It depends if you created a boombox or a flashlight. So if I say val boombox of type boombox equals new boombox, and I do .use on that variable called boombox, that's going to be this use method. If I created a new flashlight and then call use through that flashlight, I'm going to get that second use method.
Okay.
It all depends on the object type. He will not. Snid Sniper doesn't necessarily speak for me. With the right deal, I might be your Valentine. Sean? You're Snide Sniper. Oh. You don't speak for me. I might want to be their Valentine, you know. I want to leave my options open. All right, the lecture is going to be live examples, and then we're back to the lecture question. So one more time, any questions about the question itself, about what I'm asking you to do for this one? All right, let's do some code. First, last time we did some live coding, we saw this anagram stuff. Now that we know about the debugger, I want to go into this anagram code, run the debugger, and just trace through a little bit and show what's happening. Give another example of the debugger and what's going on in this thing, in this big method. So just recall, I'll run through it real quick. Anagrams, I get an input string, and I want to return a list containing all of the anagrams of that list. So every possible way we can rearrange the characters of the input string. So I create a list that's going to store all of my outputs. If I get an input of length 1, and I rearrange this just slightly since the last lecture, I just put the conditional up top. If the length is 1, I'm just going to return a list containing that string itself. A string of length 1 is itself its only anagram. So just return it. Else, remove the first character from that string, or remove each character, I should say. Remove each character from that string one at a time. Pull that character out, create a new string with that character removed, and then call this method itself on that new string. So give me all the anagrams of this string, which is the original input, but with one character removed. That's going to return all the anagrams, iterate over all those anagrams, and append that character that we removed to each one of those. And that should give us all the anagrams for the larger input. And then we had one extra change. If our output already contains that anagram, don't add it again, so we can remove these duplicates. If we have duplicate letters in the input, we don't want to duplicate all those anagrams in the output. And then append to the list. We had tests, we did A and Fox, and here's where I want to set my breakpoints. We can set breakpoints inside our tests too. Our tests run like any other programs. There is a main method somewhere. I'm going to regret doing this, I know, but inside funcsuite like, I knew I would regret it. I'm not going to find it in time. Test suite. Extend suite. Shouldn't have went down the rabbit hole. I know better. I know better than this. Well, anyway, somewhere in there should maybe be a main. Maybe actually there isn't. Doesn't matter. I said I'd regret it, and I did. But somewhere in there is going to be a main method called. It might be in Scala itself, somewhere else. Let's pretend that didn't happen. So let's go into our tests. I got my breakpoint right at where we're going to run a test case. And let's run this in the debugger and see what's going on step by step. All right, so we have our debugger running, and we can see our input-output pair. We have an input of A, the string, and our output, I really wish I could zoom in down here. Our output is a list containing just A. So we're in that first test case of the map. Just by chance, the ordering of a map doesn't matter. It might be preserved, it might not, but we did happen to get A as our first input and our output of list. So I'm going to step through this one step at a time. And just a quick side note, you can see there's a lot of frames on my stack right now. When you run the, when you run the test suite, that's all the overhead of the testing. There's a lot going on behind the scenes before your code is even called. It's setting up all of the testing from Scala test, which somewhere in here, Scala test runner, that's where it ended up being our main method. I should have just did that to begin with. Just go to the top of the stack. So let's step through this and see what's going to happen. We know what's going to happen. Our input is length 1. It's just going to return. So let's make sure that that is what's actually happening. So input length 1, it sure is. Our input is just the character A. Return it. We're going to check. We have the output is just A. I have this all in one line, so unfortunately we don't get to see, actually we do get to see that. These sorted values, we will actually get to see those calls to sorted, right? No, we got the calls to assert. But somewhere in there, the sorting happened. And A in the list A, that is going to be the same, so good, test case passed. Good. It's not really the one I want to talk about, so let's get to the next one. We're going to have Fox, and we expect the output to be all these anagrams of Fox. So let's call our method with the input Fox and see what's going on inside our method. So first, input Fox, length equal 1, false. We're going to run the else, and we're going to iterate one character at a time. We're going to start with the F. Character is going to equal that F. We're going to pull out that F from the string, so new string is going to be OX. And then we're going to call anagrams of that new string. Anagrams of OX make the recursive call. So now we have a frame on the stack with the input fox that's waiting right here for this return. But then we put another frame on the stack to call anagrams again and go through this again with OX, pausing the execution of that other method, just like our test suite is paused waiting for this method to return. We're waiting for that method to return right there. So let's step through this again. Length equals 1 false on OX. Pull out the O. Call this with just X. Put another frame on the stack. The input is just X. Length 1 true. Return X. Now that we have our return value, we're back in the call on the stack frame where the input, it's not going to show it in there, I got to go down here, where the input is OX. We're back on in this frame. We got the return value of our new anagrams of just X. It was just a single character. And now we're going to append that character we pulled out, that O. We're going to append that to each of these anagrams. Nothing's in our output list yet. And we got output. Oops, I'm holding control. And now our output has XO. We have one string, one partial anagram in there. We're going to do the same thing with just O. Let's step through this a little bit. We're going to add O, just returned O. We're going to append X to it. That was the character we pulled out on this iteration. And now, right? Now we have OX and XO on the input OX. Oh, this is the, oh, we already got here. I might skip through it a little quick. So now we're back to the input of FOX, Fox. We just called anagrams of OX after pulling out the F. We have our anagrams of OX and XO, all of the anagrams of OX, and now we're going to append F to each one of those. So now we go through our anagrams, and right here I want to show, it already happened a few times, but this is where I want to stop and show it. If I look at this list, I have this immutable list at 2023, and when I add a value to this, did I go into a recursive call? I did, didn't I? No, I didn't. Like that's I'm going to blame that on the debugger. Because my output is empty right now. But it's not really. Okay, I think I just missed something quick as it happened there. But I have my list of 2023. I just appended OX with F appended to it, so OXF, and I'm about to append XOF to it. But when I do that, once I have my list of size 2, notice that my reference changed, 2039 now. When I did this operation, when I append a value to this list and reassign it to the list, I am, in fact, as I said when we first talked about lists, creating a brand new list and returning that list. I actually didn't change the original list that I had as the output. I'm creating a brand new list, which we can tell because it's at a different memory address. It's at a different reference. And then that's the list I'm working with now. So that's why we have to reassign those lists. If I just say output, append, we'd have to go the other way around. When I just do output, prepend this new word, this, since I don't reassign back to the list, I'm creating a new list, creating the new list, but then not assigning it to any variable, so it doesn't actually do anything. It doesn't actually make any change to my program. And I believe with that change, it should break. did pass. It didn't reflect the change in the middle of debugging. So we can see that that recursive method is putting more frames on the stack each time we call it. And also we can look at the references to that list and see that that list is actually becoming a brand new list each time we append to it. Any questions on this one? All right, let's get to the more live coding instead of looking at what we did last a different time. So here what I want to do is write a player class. Thinking about the jumper game a little bit, I want to create a player class that's going to be able to maintain an inventory of items. So I want a separate class, a game item class that's going to have a string description. And I want two methods, one to be able to pick up items and one to be able to drop items. And I want to make sure that these are happening by reference and then test the functionality, make sure things are happening by reference. So let's start with the simple part. I'm going to create a game item class. Very simple class. It takes in a string value named, I think I just said DEC, DASC. Let me check my write-up quick. Make sure I did name a description. Make sure I have the exact right name. That's a common problem in Autolab, especially early in the course. If you don't have the exact spellings, everything breaks. You saw the same thing in 115, but we still get those questions every so often. But make sure it's exact. What I like to do is what I just did, cut and paste directly from the description. Then you know you have the exact spelling. You don't have to squint your eyes and try to figure out if you have it character for character right. Just cut and paste it. The names are always going to be right that way. So I have my whole game item. It has a constructor. It takes a variable, a value named description of type string. I have a value named description of type string. Class done. That game item class is it. That's all it needs to be. So now let me work on this player class. This is where we have a bit more functionality to build. So I want a class named player. It's going to follow the physics engine way of having a location and dimension. We're not actually going to mess with those in this lecture unless we have enough time at the end. But let's add them. Location of type physics vector. Dimensions of type physics vector. And I have our physics vector in this class. Same one from the homework assignment. It's going to default to 0, 0, 0. It's going to be a 3D vector, 3D representation of a vector with a nice toString to be able to print it out, make it pretty when I print it out, make it meaningful. So with that, I have the first criteria met. I'm meeting that spec. I could change these to val so I can check them. Val or var if I wanted to. We're not going to mess with those again, so let's get to the good part here. I need to maintain an inventory of game items. I need two methods, pick up item that returns unit. Now I was a little lacking in the description just because I knew I was the only one that really needed to interpret this one. But it should, by implication, take a game item as its parameter. So I'll name it item, game item, and I need to be able to store that in my inventory and also drop item by description, which is going to remove a game item from my inventory. So I need to be able to pick up items and drop items. So I'm going to need some way to store these items. I'm just going to use a list for that. So I want my inventory as some data structure. List is simple enough. A list of game items. And create an empty list to be able to store those items. So now whenever I pick up an item, I want to add this thing to the list. I'll add it to the end of the list for good measure. That should be 2 colons. And then before we get to drop item by description, let's start our tests and start testing in parallel as we develop. There are a lot of different, there's arguments to be made for each, like when do you test? After you write the code, that's kind of the natural thing people end up doing. In parallel, like I'm doing here, it's fine, plenty of arguments for that. There's also a lot of arguments for something called test-driven development, where you actually write your test cases first. Start with your testing, and then write your code after. A lot of people really promote that. I'm more on the fence when to do testing or not. Some of my colleagues really push test-driven development. They swear by it. So whatever works best for you for the time being, go for it. Tests, I need a test player. And I want to test some of this functionality. I want to create a new player with a new physics vector. I'll just do 0, 0, 0 for my physics vectors. I need to import that player. Of type player equals player1 dot pickup item. New game item of, we'll pick up a potion, we'll import that. And I want to assert, let's start with the easiest assert here, and we'll assume that my inventory variable was defined in the spec. Just the simplest test. I'm not even checking if I picked up a potion. I'm not checking the references yet. I just want to check, is my inventory size 1 at this point? Is this going to pass? Oh, I can't do that and run. Come on. Oh, come on. I found objects, import physics vector. We'll get there. We'll get there. Passes. I actually meant to screw that up. I meant for this to be colon plus. That's why I had colon equal, and I was thinking colon plus. So, would this pass? This is what I meant to do. Does this one pass? No. Damn it. Oh well. So this one doesn't pass. This is what I meant to show. So. And then fix it with the colon equal. So let's set our breakpoint. We have a test that's not passing. We know why now because I spoiled it. But let's run through the debugger and see why that failed. Let's see what happened there. So let's set our breakpoint right before the pickup item. Run this in the debugger and take a look at what we did. So the length was 0. It should have been 1. We create a new player. It has 0, 0, 0s for its vectors and an empty list. I'm going to pick up a game, create a game item. It says description. I'm going to pick up that item. But after I pick up that item, my inventory is still null, and then, of course, fails the test. Because we have to make sure, let me spell it out more explicitly, this dot inventory has to equal this dot inventory with that item added. Usually, the first time I had that : equal, which is going to be the same as : equal is the same as this, similar to the plus equal, minus equals, those methods. This is what we had with the : equal. Now we run this test, and of course, we're passing. But let me set a breakpoint right here, go back into the debugger, player 1. This list is nil at 1648. Nil. But as soon as I hit that reassignment, I created a brand new list at 1661. It is a brand new list. I have to reassign it back to that variable, and that variable has to be a var. I can't use val for my data structures if I expect them to be changing, because I have to reassign it a brand new list because these lists are immutable. They cannot change ever. We can't go to the heap and change the values in a list. We have to create a new list. All right, so we got that far. We're adding that game item to our inventory. What if I want to drop an item by description? Let me do the default. The default here, if the game item does not exist in the inventory, drop a new item with an empty description. Empty string is the description. Just some way for us to indicate that it wasn't found without having to return a null. We would set this up in different ways. Later in the course, we probably will. We would have a game item class called none item, but for now, let's just return a new item with an empty description, just to tell our test case what to expect. So new game item, empty description. I want to return that. And then if an item with this description is in my inventory, I want to return that item. So now for item in my inventory, if item dot, oh my goodness, item dot description equal DSC. To return equals item. This was supposed to be a string. Anyone with a strong Java background panicking right now that I have the equal there? If not, I'm sick of saying that if you have a Java background, there's this thing and explanation. If I'm not talking to really anybody there, I'm gonna not really bother. The very quick description, if you are worried about that, equal in Scala does call the dot equals method, so we don't have to do dot equals when comparing strings in Scala. This will call. Oh my goodness. I can't go to it. Come on. Well, anyway, that is a method that calls, you have to take my word for it, that does call the dot equals method. So I'm going to return this item. And we know we would expect this to work. Whatever the last item in our inventory is that matches that description, that's what's returned, or it's going to return this new game item. What I want to talk about is I want to mess this one up. I want to say to return equals new game item and actually I got to remove this from the list. Oh no. Oh no. Drop of N. Anybody know off the top of their head how to drop well? How to remove one item by reference? Oh my goodness, it's not saying remove is a method at all. Just drop, and that's.
I think that's by index.
Yeah, that's by. And I think that's going to drop that many items. Oh no. Oh man, I don't want to get. I mean, we'll just pretend that we removed it. Oh my goodness. This is not something I do very often, is remove from a list. But I should be able to have a method that returns a new list that This is gross, but let's do this. Well, I got to get this working at least. So found equals I. It's disgusting. Don't remove from a list this way. When you have Google readily available, don't do what I'm doing here. Hey, we got there. That's what's important. Yeah. There's an easier way to do that, I guarantee it. And actually, this is fairly strange. So hey, this is the point of testing. We're going to test and make sure that this crazy thing works. So let's go to our tests. And what I'm doing intentionally wrong here is I'm returning a new game item with the same description. So if we're getting that returned item and saying if that description is the same description, so I want to say val returned item of type game item equals player one dot drop item by description potion assert returned item dot description equals potion assert. To be honest, I'm going to sweat this one a little bit, but inventory dot size equals 0. We'll it wants me to do dot empty is empty. we'll see. We'll hope that one passes. So both of these should pass if we got everything right. Let's learn together. Hey, all right. But we check this by description. How do we write a test that's going to tell if this is the exact same item that we want? Well, we're going to go up to our reference of this item. I'll name it potion of type game item equals that new potion. This player is going to pick up that potion. And now I'm going to check if this returned item equals that same potion. So I gave the user a potion. I told them to drop a potion. They only had one potion in their inventory, so I don't have to worry about which potion was dropped. I know they had to have dropped this potion. So I'm going to check those by reference. When I do equal equal on a game item that I didn't override the equals method is what we'll see next week. I didn't tell it how to compare two game items. So the default is comparison by reference. This is going to say, does returned item refer to the same game item as the variable potion? Do these two variables hold the same reference to the exact same item? We know that they both have the same description already. We know that. They're both description potion. So all of their values, their one instance variable, state variable, is the same, has the same value. But are these equal? Of course not. They're not the same potion. So let's run this. It should fail. Our test failed. Let's debug to figure out why. Potion, returned item. Yes, they do both store potion, but at 1637, at 1638. These are two different potions. They have two different references. They are not the same potion. This is not the same potion that the player picked up. They didn't drop the right potion. So we can test that using equal equal, using that default equal equal behavior. We can get rid of this new potion and actually return this exact game item. Restart our debugger. Compiling. 1637. Resume the testing. Test passed. So that's how we can test to make sure that we are handling these by reference instead of by value. Make sure that those references match. Do these refer to the same reference? And to do that, we usually have to create these extra variables. I can't just inline say new game item here. We have to create that separate, store the reference, so we can compare that reference later. We need a reference to this game item. We need that reference so we can do our testing afterwards to make sure that everything did, in fact, happen by reference. And for good measure, obviously this is not enough testing. We gave the player one item and made sure that they returned that item. So let's give them a few more items. Returned item, cleverly named 2. Make sure they return that ball. Returned item 2. Should be ball, which we don't really have to check since we're going to check by reference as well. Returned item 2. I need a reference to this ball. inventory dot length should equal 2. And furthermore, you know what, I do want all these in. Let me just do one more just to make the point. Call it health potion. I want to make sure that my inventory does still contain the other items. I just want to I want to check everything with my inventory. I would do a lot more testing to fully test all this functionality. But let's do this for now. I'll just run this without debugging for now. And we would expect all this to pass. Hopefully it all does. Doesn't. Game item has link. Oh, yes. And make sure you update your tests, your certs when you update your tests, of course. I added 4 items and made sure there's only 1 item in there. And our tests do pass, so we're happy with that. So that means this line, we don't really have to check it, but we could make sure that it does work. Let's run the debugger for good measure. So we removed, like I didn't even test if the item isn't in the inventory. That's something I should have checked. So this dot inventory has these 3 values. My description is ball, so I expect inventory, which is now 1661, to be some different reference referring to a list that doesn't contain ball after this line is called. 1952, and we get a list that doesn't contain ball. So we got the proper behavior there, and we can run the debugger, step through our programs, and see all of that behavior as it's happening. We can take away the mystery of looking at a blob of code and going, what's actually going on when I hit the go button? Run the debugger, actually walk through your program, and you can see everything that is actually happening underneath the hood as that's running. Any quick last-second questions? Have a good weekend. Have a good Valentine's Day. See you Monday.